Lagrange interpolation formula, what is the beauty of this formula? There is no need of any difference table. Directly we putting the value of argument and entities means the value of x and y in a formula and be able to find out the value for what? Value for y for any given unknown value for x. So how we first derivation of a Lagrange interpolation formula. So first we derive the Lagrange interpolation formula, then we define a Lagrange multiplier. After defining the Lagrange multiplier and then we study some property of a Lagrange multiplier, then we solve a numerical example based on a Lagrange interpolation formula. So Lagrange interpolation formula is specially designed for the unequal class interval, but we also able to find out the values of y for equal class interval also. Value for y for equal class interval also. So first of all, we derive the Lagrange's interpolation formula. Interpolation formula. So Lagrange interpolation formula. So suppose there is a n or n plus 1 argument is given, x0, x1, x2 up to what? xn. There is n plus 1 arguments or n plus 1 values of x and corresponding value of f is also given, f of x0, f of x1, f of x2 up to what? f of xn. f of xn. So this one is a tabular value, means for n plus 1 argument we have a n plus 1 corresponding function. So as in our interpolating formula, we assume that the polynomial of a degree n if we have a n plus 1 argument and corresponding value of a function. So here we assume that this one is a polynomial of a degree n, y equal fx equal what? a0. Our aim is to write a polynomial of degree n. So this one have how many number of terms? There is a n terms. So this one is a polynomial of degree n. Similarly, here we write what? a1. There is a x minus. We started from x minus x0, x minus x2. There is a missing term x minus x1. There is a missing term x minus x0. From x0 to xn there is an n plus 1 term, but there is a missing term x minus x0. So degree of this one is a what? Degree of this one is a n. Similarly, here x minus xn. So what is the degree of this one? Degree of this term is also a n. So in this manner, what is the nth term? The nth term become what? an x minus x0, x minus x1 up to what? x minus xn. X minus, not xn here we write xn minus 1. xn minus 1 because here x minus x0 is missing, x minus x1 is missing, so here x minus xn is missing. So this one is a polynomial of degree n. So how we find the values of a0, a1, a2 up to an? So how we find the values of a0? In all other terms except the first term, there is a factor of a what? Factor of a x minus x0. There is a factor of x minus x0. In the next term also there is a factor of x minus x0. In the last term also there is a factor of x minus x0. So if we put x equal what? X equal x0. X equal x0, then what will happen? This become what? Right hand side become f of x0. And this may be also written as what? y0. This one equal what? a0. Here x become what? x0. So x0 minus x1, x0 minus x2 up to what? x0 minus xn. So what is the value for a0? The value for a0 become what? The value for a0 become y0 or f of x0. F of x0 divided by what? Divided by x0 minus x1 x0 minus x2 up to what? x0 minus xn. This one is the value for what? This one is the value for a0. Now, similarly, we find the value for, put the value for x equal x1. X equal x1. X equal x1. Then first term becomes 0, but second term does not equal to 0. Third term, fourth term and nth term also become 0. So what is the value? If we put x equal to x1, then f of x1 equal what? F of x1 equal a1 x1 minus x0 x1 minus x2 up to x1 minus xn. So what is the value for a1? The value for a1 become what? Value for a1 become f of x1 divided by what? Divided by x1 minus x0 x1 minus x2 up to x1 minus xn. Similarly, what is the value for an? If we write the value for an equal what? F of xn. F of xn divided by what? Divided by xn minus x0 xn minus x1 up to what? xn minus 1. So in this way we able to find out what? By putting x equal to x0 we find the value for a0, by putting x equal x1 we find the value for a1, by putting x equal xn we find the value for an. Now putting all the values in this polynomial means a0, a1, a2 up to an, then we find what? Then we find a general Lagrange interpolation formula, means putting the value of a0, a1, a2, this become what? Y equal fx equal what? X minus x1, x minus x2 up to what? X minus xn divided by x0 minus x1, x0 minus x2 up to what? x0 minus xn. This one is a y0 is f of x0. This one is a, by putting the value for a0. This one is the value for a0 here. What is the second one? Second one is the second term. X minus x0, x minus x2 up to x minus xn divided by what? Divided by x1 minus x0, x1 minus x2 up to what? x1 minus xn f of x1. F of x1. So similarly, what is the nth term? Nth term become what? Nth term become x minus x1, x minus x2 up to what? X minus xn. X minus x0, x minus x1 started from 0, 1 to up to n minus 1. In a denominator this become what? Xn minus x0, xn minus x1 up to what? Xn minus 1. This one is a what? F of xn. This one is a what? This one is a Lagrange interpolation formula. So this one is a what? This one is a Lagrange interpolation formula. This one is a Lagrange interpolation formula. This one is a what? This one is a Lagrange interpolation formula. This one is a Lagrange interpolation formula. So now if we try to analyze this Lagrange interpolation formula, means some properties of a Lagrange interpolation formula. Now here we write in terms of a Lagrange multiplier. This one is a what? This one is a Lagrange multiplier. This term is a what? Lagrange multiplier. This term is also a what? Lagrange multiplier. Lagrange multiplier. This term is a what? This term is a what? This term is also a Lagrange multiplier. So if we write in terms of a Lagrange multiplier, y equal fx equal what? This one is a zeroth order Lagrange multiplier. If we write here, this one is L0 x f of x0 plus L1x f of x1. Similarly, ln x f of xn. So if we write in terms of a summation, so this one is a what? I equal 0 to n L I x fxi. So I equal to 0, L0x f of x0. At I equal to 1, L1x f of x1. L2x f of x2 up to ln x f of xn. So this one equal what? This one is a Lagrange interpolation formula in terms of a Lagrange multiplier. In terms of a Lagrange multiplier. This one is a value for what? This one is a value for L0x. This one is a value for what? L1x. And this one is a value for what? This one is a value for ln x. So, if we closely observe these Lagrange multiplier, so what is the value for L0 x0? Means in place of x we put x0. Then what will happen? x0 minus x1, x0 minus x2, x0 minus xn divided by x0 minus x1, x0 minus x2 up to x0 minus xn. Means numerator equal to the denominator. So if we put x equal to x0 here, the numerator become denominator. So if numerator become denominator, then what is the value for this one? The value of this one is a 1. And if we put x equal what? X equal x1, then what will happen? This becomes 0. x1 minus x1, this one becomes 0. If this one becomes 0, then all the term become what? All the term become 0. Means L0 x1 become what? 0. So for all other values, because this one is a multiple of x minus x1, this one is a multiple of x minus x2, this one is a multiple of x minus xn. So if you put x equal x1, this term becomes 0. X equal x2, then this term also becomes 0. X equal xn, then this term becomes 0. So rather, other than x0, if you put x1, x2 up to xn, all other values become 0. L0 x2 is a what? 0. Similarly, L0 xn is a what? L0 xn is also a 0. So what we conclude here? We conclude here, we find a summation of a what? Summation of a L I L0 xj, and this one ranges from what? J ranges from 0 to n. So what we conclude here, if the value for x0, then this one is a 1, and for all other values from 1 to n, this one become what? This one become 0. So what is the value? Value become 1. This is a what? This one is a 1 property of a Lagrange multiplier. Now if we describe the second property, means what is the value for L1 x0? This one is again a 0. But if we write L1 x1 become what? L1 x1 equal to numerator become denominator, so L1 x1 become 1. So what we predict here, means what we analyze, what is the property for this Lagrange multiplier, means L0 x0 is a 1 and all other values L0 x1 x2 all other values with a 0. Similarly, L1 x1 is a what? 1. Similarly, L2 x2 is a what? 1. So if we write this one in terms of a summation, means I equals 0 to n, and second summation j equals 0 to n. J j equals 0 to n, then this become what? Li xj. Xj means if I be the 0, L0, xj varies from 0 to n. This one have how many number of terms? 1 plus 1 plus 1. How many number of a term? N plus 1 term. So sum become what? N plus 1. So this one is a property of a what? This one is a property of a Lagrange multiplier. So now next we solve a numerical problem based on a Lagrange interpolation formula. Okay, now we solve some numerical problem based on a Lagrange interpolation formula. So first we take a very simple example. In this example, we try to interpolate the value of a 9.5. Means what is the value for y at x equal 9.5. So using the Lagrange interpolation formula. So just we write a Lagrange interpolation formula, then we put x equal what? X equal 9.5, and here if we write this one is a what? This one is a x0, this one is a x1, this one is a x2, this one is a x3, then and corresponding values of will be the y0, y1, y2, y3. So what is the Lagrange interpolation formula for 4 terms? If we write directly, y is a what? Y equal fx equal what? L0x, y0 plus L1x, y1 plus L2x, y2 plus L3x, y3. Now just write down the values of a Lagrange multiplier in a 4 term, and L1x, L2x, L3x also in term of a x0, x1 and x2. So what is the value for this one? This become x minus x1, x minus x2, x minus x3 divided by what? Divided by x0 minus x1, x0 minus x2 and x0 minus x3. And here this one is a y0. Similarly we write L1x is a what? X minus x0, x minus x2, x minus x3 divided by x1 minus x0, x1 minus x2, x1 minus x3, and this one is a y1 plus third term is a what? X minus x0, x minus x2, sorry x1, x minus x3 divided by x2 minus x0, x2 minus x1, x2 minus x3 into what? Into y2. And what is the last term? Last term is a what? Last term is a x minus x0, x minus x1 and x minus x2 divided by what? Divided by x3 minus x0, x3 minus x0, x3 minus x1 and x3 minus x2, and here we write the value of a what? y3 into y3. Just put the values of a x0, x1, x2, x3 and y0, y1, y2 and y3. We find what? We find a desired solution. So desired solution. So desired solution is a means what we try to find out the value of a y at x equal 9.5. So we put what? X equal. So here we try to find what? Find the value of a y 9.5. What is the meaning of this one? X is a what? X is a 9.5. X is a 9.5. Now if we write here y equal what? Here just put the values of x1, x2 and x3. So 7, 8, 9, 10. This one is a value of x0, x1, x2 and x3. So here we write what? X is a 9.5. 9.5 minus, sorry, 9.5. Here x be the 9.5 minus x1 be the 8. 8, 9.5 minus 9 and 9.5 minus 10. 9.5 minus 10 divided by what? Divided by x0 minus x1. 7 minus 8, 7 minus 8, 7 minus 9 and 7 minus 10. 7 minus 10 into y0. The value of a y0 is a what? The value of a y0 is a 3. This one is a first term. Similarly, we write what? Similarly, we write the second term. Second term is a what? 9.5 minus 7, 9.5 minus 9, 9.5 minus 9 because this one is x2 and next one is a 9.5 minus 10 divided by what? Divided by x1 minus x0. What is the value of x1? x1 is 8. So here this one is 8 minus 7, 8 minus 9 and this one is 8 minus 10. 8 minus 10 into y1. What is the value for y1? y1 with the 1 into 1. Now next term is a what? Plus 9.5 minus x0, sorry, minus x0 with the 7, 9.5 minus x1, 8 and next one is a 9.5 minus 10 divided by what? Divided by x2 minus x0, x2 with a 9. So 9 minus 7, 9 minus 8 and 9 minus 10 into what? Into a y2. y2, the value of a y2 is a what? 1 plus last term is a x minus x0 means 9.5 minus 7, 9.5 minus 8 and 9.5 minus 9, 9 divided by what? Divided by x3, x3 with a 10. 10 minus 7, 10 minus 8 and 10 minus 9 and multiplied by what? Multiplied by y3. This one is a what? 9. So if we simplify this one, if we simplify this result, so what is the value? If first we erase this one. So what is the value? Here we noted down the values of this one. What is the value? Value for y is a what? Value of y is a y at what? At 9.5 or you may also write this one is a f 9.5. 9.5. What is the value? 0.1875. After calculating this value, this one becomes 0.1875. And if we calculate the second value, this one is a minus 0.3125. 0.3125 and next value is a 0. Plus 0.9375 and if we calculate the last term, this one is a 2 plus 2.8125. 2.8125. So already we have noted down these values because you cannot calculate manually means without help of a calculator. So with the help of a calculator, if you calculate the values of this term, this term, this term and this term, once we verify the values, this one is a 0.1875, minus 0.3125, 0.9375, 2.8125. So Now what is the result? Now result become 3.625. 3.625. So what we can include here, if x0, x1, x2, x3 is this one, y0, y1, y2, y3 is this one, so what is the value for y at x equal 9.5 with the help of a Lagrange interpolation formula? So what is the procedure? Just write down a Lagrange interpolation formula in terms of a Lagrange multiplier, then write down the values of a Lagrange multiplier according to the number of terms, then putting the values of x0, x1, x2, x3, y0, y1, y2, y3, we able to find out what? We able to find out value of a y for a given value of a x. So here this one is a 3.625. In this example, if we closely observe the data, in general we say that Lagrange interpolation formula is a true for what? For unequal class interval, especially designed for the unequal class interval, but you may also apply the Lagrange interpolation formula for the equal class interval. So in this example, the class interval among the arguments is a what? 1. Difference between 8 to 7 is a what? 1. 9 to 8 is a 1. 10 to 9 is a 1. This means this problem can be also solved 9.5 with the help of a what? Backward interpolation formula also, because this one is an equal class interval. This data is available with equal class interval, and we try to find out the value of y 9.5. 9.5 is nearer to the last value, so we also able to find out the value of y at x equal to 9.5 with the help of a backward interpolation formula also. So Lagrange, with the help of a Lagrange interpolation formula, not only we interpolate the value for unequal class interval, we also interpolate the value for equal class interval. That's why, and similarly, with the help of a Newton divided difference formula, which is especially designed, especially means derived for the unequal class interval, but you may also find you may also find the value of a y for given value of x, means you may interpolate the value of a y if the data is given for equal class interval also. So equal class interval also. So this one is another example, means how we find the value of a y for given value of a x. Now next we solve another example in which first we find a polynomial, then in a polynomial we put the value what? We put the value of a x to find out the value of a y. So rather than to directly we put the value of x here, first we put the x equal x in a Lagrange multiplier, then we find the value of a y in term of a x. In term of a x means we find the value of a y, we find a polynomial, and once we find a polynomial, then we put the value of a x to find out a what? To find out a solution. So here if we try to write one another example, and we try to find out a solution of we try to solve one another problem using the Lagrange interpolation formula. So in this example, find a polynomial using Lagrange interpolation formula, hence find y at x equal to 1. What is the meaning of this one? With the help of this data using a Lagrange interpolation formula, first we find a polynomial, then we put x equal 1 to find out the value of a y. So how we find the value of a y at x equal to 1? So first we find a polynomial. So simply, as usual, first we write what? First we write a Lagrange interpolation formula. So what is a Lagrange interpolation formula? Again, this one is a y equal fx equal what? L0x y0 plus L1x y1 plus L2x y2 plus L3x y3. And here if we denote these values by the what? x0 is a -1, x1 is a 0, x2 is a 2, x3 is a what? 3. y0 with the minus 8, y1 with the 3, and y2 with the 1, and y3 with the 12. So if we write the values of L0x, L1x, L2x, L3x, so here if we started from here, now what is the value of L0x? Y equal fx equal what? In a x0, x1, x2, x3 term, what is the value of L0x? X minus x1, x minus x2, x minus x3 divided by what? Divided by x0 minus x1, x0 minus x2, x0 minus x3. What? Multiplied by the y0. Multiplied by the y0 plus, similarly we write what? Similarly we write for the L1x. What is the value for the L1x? X minus x0, x minus x2, x minus x3 divided by what? Divided by x1 minus x0, x1 minus x2, x1 minus x3. This one is a what? Y1. Similarly, we write next two term is a what? X minus x0, x minus x1, x minus x3 divided by, this one is written for the y2, so x2 minus x0, x2 minus x1, x2 minus x3, y2 plus x minus x0, x minus x1, x minus x2 divided by what? Divided by x3 minus x0, x3 minus x1, x3 minus x2 into what? Into a y3. So just put the values of what to find out a polynomial. Just put the values of x0, x1, x2, x3, y0, y1, y2, y3. And in place of x, we write x as it is. So what is the value? Now if we simplify here, means we write a y, because there is a 4 terms, so he started from here. Y equal what? Y equal, here we write y equal f of x equal x minus 0, x minus 2, x minus 3 divided by, what is the x0? x0 is a minus 1. So minus 1, minus 0, minus 1, minus 2, minus 1, minus 3. What is the value of a y0? y0 is a minus 8 multiplied by minus 8. Similarly, what is the second term? X minus x0. So x minus plus 1 minus minus 1 plus 1, x minus 2 and x minus 3 divided by what? Divided by x1 minus x0. x1 with a 0, so 0 minus plus 1, 0 minus 2 and 0 minus 3 multiplied by what? Multiplied by y1. y1 is a what? y1 is a 3. And what is the third term? If we write a third term is a what? Third term is a x minus x0. X minus x0 means x plus 1 and x minus x1, x minus 0 and x minus x3, x3 with a 3 divided by what? Divided by x2 minus x0 means x2 with a 2, 2 plus 1 and 2 minus 0 and 2 minus 3 multiplied by what? Multiplied by the y2, and what is the value for y2? y2 is a 1. And what is the last term? Last term is a what? X minus x0, x minus x plus 1, x minus x1, x minus 0, x minus 2 with a 2 divided by what? Divided by 3 minus 0, 3 plus 1, 3 minus 0 and 3 minus 2 multiplied by what? Multiplied by y3. This one is a what? This one is a 12. So if we simplify this one, we have already write down the values of this one is a what? The value of this one is a y equal what? Y equal 2x cube square minus 6x square, 2x cube minus 6x square plus 3x plus 3 plus 3x plus 3, 6x. This one is a 6x. Now just we verify the value of this one, 2x cube minus 6x square plus 3x plus 3. This one is a polynomial. So to find out the value of a what? At x equal to 1, what is the value of a y? So here just we put x equal to what? X equal to 1. So y 1 equal to what? 2 into 1 cube minus 6 into 1 square plus 3 into 1, 3 into 1 plus 3. So if we simplify, this one is a 2, this one is a minus 6, this one is a plus 3, this one is a plus 3. So this one 6 minus 6, this one is a what is the value? Value become 2. So what is the value? Value become 2. So at x equal to 1, what is the value of a y? Y become 2. So what we conclude here, this one is a what? This one is our polynomial. This one is a polynomial. And this one is a what? This one is a value of y at x equal to 1. These are the result. And what is the data? Data is this one. This one is a data. 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 So this one is a data. This one is a value of x. This one is a value of y. So there exists a polynomial which satisfy this data. And if we put x equal to 1, x equal to 1, then we find y equal what? Y equal to 2. So we also verify at x equal to 0, what is the value? X equal to 0, 0, 0, 0, and what is the value? Value is a 3. So I think this one is a correct answer because we verify the answer at x equal to 0. So this one is all about Lagrange interpolation formula. So here first we discuss derivation of a Lagrange interpolation formula, then we solve some numerical example based on a Lagrange interpolation formula. Okay, thank you.